Hello guys, welcome back to MedZone African Motives. We are still on our algebraic expressions, working with our trinomials. Remember we had the first part where we talked about basic factorization. I want you not to have a confusion. Please do not have a confusion here. We had a normal factorization of this nature where we are given x squared plus maybe 5x plus 6 like this, okay? And I told you guys that whenever you are being asked to factorize this type of an expression, this one, which is a trinomial, we've got 1, 2, 3 terms, okay? So we've got 3 terms in this whole expression, which is a polynomial that we have. This makes it to be a trinomial. And I said, whenever you're given this type of an expression and this first term, which is the coefficient of this one, with 1 that has got the highest exponent, which is 2, if you see that the number that is here, it's a 1, which is the value of a, remember that this trinomial can be given as ax to the exponent of 2 plus bx plus c. This is the normal expression, how it is supposed to be with the 3 terms, okay? 1, 2, 3. So this a here, we talked about this when a is equal to 1. We referred to that when a is equal to 1, if you still remember. Okay, so just for a catch up for those who are not part of that class, we said when it is like this, you open 2 brackets, okay? Just open 2 brackets. You consider that you are supposed to obtain x squared. So remember on your expansion, on your distributive or on your FOIL method, whereby this multiplies here and it also multiplies here. Remember that. So in order for you to multiply here and you get x squared, it means there must be x here and there must be x here. Remember, 1 and 1, if you multiply 1x times 1x, you get what? 1x squared. So if you multiply these two here, you get x squared. So it means this is just going to be x, this is going to be x. So on a condition like this, once this is 1, I told you that you focus on this term, the constant, okay? So you put your eyes on here, you're going to focus on this constant, which is 6. What you're going to do is that you're going to find numbers that you multiply to get a 6. But these numbers, they must add up to 5. So you need numbers that multiplies to what? That multiplies to positive 6. So these numbers that will multiply to positive 6, they must add up. All right, let me just write this. They must add up to a positive 5, which is a 5, this one. So you just need factors of 6, 2 numbers. So if you do not know this, I told you that you go back to your product of prime factors from your grade 9. We talked about our factors, okay? 6, this because we need numbers that we multiply to get a 6. So we express this as a product of its prime factor. The smallest number here, it's a 2. The factor of 6, okay? We've got 1, 2, 3, and so on. So one we're gonna consider it on 6 and 1 says just 1 and 6, okay? 1 and 6, but on the prime factors, you start with what? With a 2. The smallest prime number, remember, it's a 2. If you talk about prime numbers, okay? You talk about prime numbers, the smallest prime number is what? Is 2. So you divide 6, divide by 2, which is a 3. As we can see, we can't divide by 2 because if we divide by 2, we're going to get a remainder. So we move on to the next prime number, 2, 3, 5, and so on. So we're going to divide by 3, we get a 1. So if we multiply these 2 numbers here, we get a 6. Okay, so meaning to say these are also factors of 6. So if I multiply 2 and 3, I get a 6. If I also multiply 1 and 6, I obtain a 6. So, but if you know these numbers, there's no need for you to write this as a product of its prime factors like this. This is a condition. If you do not understand your numbers, you can go back to the product of its prime factors. Then, like I said, if you have these 2 numbers, what you do is that you test them, okay? Because you know these are the numbers that you can multiply to get a 6. If you multiply 2 and 3, you get a 6. If you multiply 1 and 6, you get a 6. But which of these numbers that when you add, you get a positive 5? If you add 2 plus 3, that's a 5. Okay, 1 plus 6, that's a 7, not a 5. So we need this one that will give us what? A positive 5. So this is from 2 and what? 2 and 3. So these are the factors that you're going to write here as a positive. 2 is a positive, so it's going to be positive 2. 3 is also a positive, so it is going to be a positive what? A positive 3. So that is how you can factorize this. It was a direct because the coefficient was a 1. So I want you to see now if this coefficient is not a 1. And also to prove this, I said if you go back to your FOIL method or back to your distributive, you're going to see that if you expand these brackets, you are going to obtain this as it is. Okay, if we expand x plus 2 into x plus 3 like this, remember that x multiplies everything in the second bracket. Okay, this is the first bracket, x multiplies here. So it's going to be x times x, which is x squared. Okay, x and x, that will be x squared. This is 1 and 1. You add, that will give you a 2. You move on, x multiplies the 3 that is at the end there. Okay, so it's x times 3, which is going to give you a 3x. Okay, you are done on this part. You move on to 2. You move on, you start with x, it multiplies everything. Okay, if you are done, you move on to this plus 2, it multiplies everything. So it's plus 2, it multiplies x, so it's going to be plus 2x. Okay, 2 and x, that's a positive. We move on to plus 2 and plus 3. If you multiply plus 2 and plus 3, that is going to be a plus 6. So if we add our like terms, that will be 2x and 3x, which is going to be what? 5x plus 6. So as we can see, if we expand back these brackets, they are giving us exactly what we had. So this is how you can prove in exam. You can just write this aside and see if you get exactly what you had in the previous question, the one that you're being asked to factorize, because it's a reverse. Okay, so now let's talk about this. I'm introducing you to this part, but I talked about this on the introduction. Let me not waste much time. I want us to talk about this one. This one, if you do not understand much, go back to the video where I talked about the coefficient of a being equal to 1. So on these questions that we are going to be working on this class, you're going to see that the coefficient of x squared, the number that is multiplying x squared, this is your x squared here, this is your x squared. You're going to see that there's a number here which is no longer a 1, okay? These numbers, there's a 12, there's a 3, there's a 2, there's this number. If you consider here, okay? If you consider here, there's a 3, there's a 2, whatever that you have there. So how do we factorize such? Okay, let us start with this together. If I am given to factorize, okay, the first part I'm given to factorize 3x squared plus 4x plus 1. Remember, to factorize is to put in brackets. We are supposed to put in brackets. So meaning to say, whatever that you're going to do in this case must end up in brackets. And whenever we are dealing with a trinomial like this, we have got 3 terms of this nature, which is of the nature of ax squared plus bx plus c like this, we end up with 2 brackets of this nature, okay? So this is how you're going to do it. You ask yourself, okay, this is, remember here, this is the most important part. Let me highlight it so that we can be together here. This is the most important part. This number here, the coefficient of x squared, okay, which we referred here as what? As a. A is no longer equal to 1, is not equal to 1. Previously, we just talked about a condition where a is equal to 1 in our previous class. But now a is no longer equal to 1. So what do? You know that you're going to have the same as guys. The condition is not going to change. We are going to have a same condition of having 2 brackets, which is true, like this, which is true. We are going to have 2 brackets, but how? You are not going to just write 3x here and you write x or whatever that you want, okay? Here it's just because there's a 1, so you think that that is exactly what is happening, okay? But this is what you do. You are going to consider the first term and the last term. So you consider, all right, you're going to consider the first and last term. Okay. What is it that am I going to consider on the first and last term? What is it? You consider their products. Okay, so guys, you can write in a better way. Okay, you guys, you're doing a better English. You can do it in a better way. Write the notes in a way that you understand. Okay, but I think you understand this. So you're going to consider the first and last terms. That is in this case. Okay, first and last terms. The first term is 3x squared, but you're considering the products to say it is just because there's a 3, so you won't see like exactly the nature of this question, but let me just explain. We'll do another one that is more advanced. You are supposed to consider the factors of 3x squared, like we are going back to say the numbers that you multiply to get 3x squared, okay? You need numbers that you multiply to get 3x squared. So 3 is already a prime number. So you can only think of 3 and 1. There's no other number that you can multiply to get 3. So it's going to just think of what? 3x and what? And 1x. Okay, that's 1x, which is same as what? Which is same as x. If it was a 6x, I want you to see this. If it was a 6x squared here, you're going to think of numbers that you can multiply to get a 6. So you think of 6x and x. Okay, this is the first term. You think also of maybe they can be 3x and 2x. So to properly know this number, I said you just write them as a product of its prime factors. 2, the smallest number, you get a 3, 3 and 1. So you can see your numbers, okay? But because this one is a 3, the only number that we can use there is what? It's a 1, all right? So this is for the first term, which is what? Which is 3x squared. We are going to have the product. Remember, we want the product. So let us just multiply so that we understand each other. So this is times 1x. If I multiply this, I get 3x squared. Okay? But like I said, you consider the first and last. Okay, I hope we'll be together at the end, because this one, most of us, we prefer working with this method. Okay? I'm going to show you another method in the next class. So make sure that you watch that video so that you'll be able to choose the method that you want. That one is best, but this one is also best because it's in your textbooks, okay? Then the last term, it's a 1, this one. This is your last term, which is a positive 1. Okay, so let us consider numbers. In fact, the sign is not even important. Let me just write as a 1 so that you don't confuse both. If you see it as a negative 1, you consider a negative 1. No, it's not like that. When you see a negative, you just consider the number as it is, okay? So the numbers that I can multiply, because I need the products. Which numbers that I can multiply to get a 1? There is just 1 and 1. As you can see, guys, it's just 1 times what? 1 times 1. Or maybe I can just write it this way so that you can properly see. So it's 1 times a 1. These are the numbers that I have. There's no other number. I can't use 2 and 1. I can't use 1 and 3. It's just 1 and 1. Okay. So this is what you do. You have these numbers here. So you're just going to tabulate something. You're supposed to have it like a sort of a table, okay? You're going to have a sort of a table like this, okay? Even I can do it this way. I can just remove these brackets because I'm supposed to factorize. I know I'm going to have 2 brackets. Just going to open these 2 brackets later on so that we understand here. So from this part, we now know that if I multiply this, I get 3x squared. If I multiply this, I get 1, which is the first and last term. So what you're going to do is to tabulate a table. You're just going to have a table, a small table, just like this, okay? Do not consider much. Just going to have your table like this, which is going to show what is happening from the first term, all right? Let me just write the first term and what is happening on the last term, okay? So the choices that you picked here, you're going to write them here. So as you can see, we only have one choice here to obtain 3x squared. There's only one choice on the first term, 3x and x. That is the only choice there. Okay, we only have one choice, only one. If there were 2 choices, you write them, those choices, but there's only one. So you're just gonna write what? 3x here and 1x, which you can just write x, but just for us all to understand, I'm just gonna write 1x, okay? For the last term also, you just read one option, 1 and 1. So there's nothing there to consider, it's just 1 and 1. You write your numbers. Okay, So once you tabulate them like this, it's only, unfortunately, we just have two terms to consider. The first, it has just got this, and the last, it has just got this. So what you have to consider is that on these terms, because remember, I'm supposed to obtain is 3x squared, okay? 3x squared plus 4x plus 1. So this is, let me do it this way. Let me do it this way. I hope you can see. 3x squared plus 4x plus 1. I'm just going to write it here. 3x squared plus 4x plus 1. This is our expression, and we are supposed to go back there and relate again. We are supposed to go back and relate. So I want you to check something here. I want you to check something. If we are to consider this, we are supposed to have like a product that you consider diagonally like this and like this. Okay. So if you consider that way, we are going to see that there is a 3x here, which goes with what? With a 1. All right. There is a 1x here, which goes with what? With a 1 here. These are the terms that you're going to need in your brackets. But you have to consider to say, this is the most important part that I want you to see, because here there are only two terms. And this type of equation is a trial and error. What am I trying to say? You try. It's not like you obtain your answers direct. No, don't get it that way. You don't get your answers direct, but yes, just because we've got two terms, so you won't see that trial and error concept. So what you do is that you test your values at this concept to say, if I multiply here, these two, okay? If I combine these two like this, 3x and 1, if I combine them, what do I get? I get 3x. If I combine 1x and 1, what do I get? I get 1x. So if I add these, am I going to obtain this number here, which is 4x? 3x plus 1x, it gives us what? 4x. So these are the actual numbers that we need. Okay? What if it was a negative here? You're going to consider the signs on this number here. Okay, I'm going to put that one. Let me finish this one. So as you have seen that these numbers, they do match with what is happening. They are corresponding to what this number that is in the middle term, which is 2x. It must correspond, which is 4x, I mean, this one. They must correspond here. Because this one, they already match, because remember, you took them from where? From the first term. So already, if I multiply this, I'm supposed to get what? 3x squared. If I multiply this, I'm supposed to get 1. Already, that one, it is us who took it. It is us who took these numbers. So it already gives us what we want. But what we do not know is about the middle term. So that's why you are supposed to test your middle term. That's why I said it's a trial and error. So we saw that these numbers, as they are 3x and 1x, they do match with 4x. If you add them, they give us 4x. So what we are going to do is to factorize now, to put two brackets. So how do you factorize? You take these numbers, because there's nothing that we changed. The signs are as they are, there's nothing that we're changing. So you take these two numbers as they are like this, okay? These are the numbers that you're going to have on x and x. Remember, they've got x and x. So you're going to have 3x here and also 1x. So this will be 3x and x and x, okay? We've got 3x and x. These numbers, they're just constants, 1 and 1. So you're going to have plus 1 here, plus 1 here. So we are factorized. So it looks like we have a lot of things to consider there, but we do not have. No, we do not have. And like I said, if you were to expand these brackets here, if you were to expand these brackets, you obtain back this expression by your distributive or by FOIL method. Okay, but let me explain this way. Let me explain this way. Okay, we have seen our answer. Okay, if here there was a -4, let's take this way, that we have got our table, this and that, everything, we have it. But let's say here there was a -4, it was 3x squared minus 4x plus 1. So as you can see, what you're going to do was not going to change because we consider the first term and what? And the last term. So meaning to say we still have 3x squared. We still have what? We still have a 1. So this table was not going to change. We are going to have the same table. And these numbers are not going to change. We're going to take them in a diagonal as it is. So meaning to say we were going to end up with 3x, just like the previous part, corresponding to 1. And this is 1x corresponding to what? 1. But now, because here there's a negative 4 in the middle term, here there's a negative what? Let me just take as it is. There's a negative 4x in the middle term. So you are, like I said, it's a trial and error. So if we take it that way to say, if I multiply this like this, 3 and x, okay, and I get 3x. And if I multiply this 1 and x, 1x and what? And 1, I get 1x. If I add these two, I am going to get what? 4x, not minus 1x, not minus 4x. So it means these numbers are not going to work, okay? So where am I going to focus on? I'm going to focus on the constants. I do not change this because these are the variables. Remember, these variables, they're the ones that we put in the first place and in the first place here. So these ones, they cannot be negative. You put them as positive because this one is what? It's a positive, okay? So that's why you don't change the sign here. You don't consider the sign on this side. You consider the sign on the what? On the constant. That's where you can change. So you can play around with these two numbers, 1 and 1. So you can test them to say, okay, if I put a negative here, what's going to happen? Okay, let's put a negative and see. 3x and x is going to give us 3x. Okay, 1x times minus 1, it will be minus 1x. And if we subtract, we get 2x, not 4x. So it means we are still not there. Okay, let's put also a negative here and see what's going to happen. Let's multiply 3x times minus 1x. You multiply diagonally like this, 3x times minus 1, it's minus 3x. 1x times minus 1, it's minus 1x, okay? This x is going to be minus 1x. So we subtract minus 3 minus 1. So from your calculator, minus 3 minus 1, it gives you minus 4, which is minus 4x, which is exactly what we have here. So it means these numbers this time, they are supposed to be what? They are supposed to be -1 and -1. So our brackets at the end, now we can factorize. These ones, they are not going to change, okay? And these are the numbers that we take in your first terms. For the first bracket and second, we've got 3x. And remember, we are supposed to get 3x squared. So if you multiply this and this, remember your FOIL method, guys, okay? Or distributive. First term, if you multiply to the first, this one, okay? If you multiply this, what is going to happen? You must get 3x squared. So it means this 3x and this 1x, they must be in the first place, both brackets in the first place. And this minus 1 at the last one, -1, -1. So that is what our bracket was going to be like. And if we expand this, if we do expand, we must go back here and obtain the same expression. So I want you to challenge yourself, expand these brackets and see if you obtain the same answer by your distribute. Just imagine you were asked a question like this, because they can even ask you like this in exam. Expand these brackets. They can even ask you like this, simplify, or they can ask you to expand the brackets, or they can just ask you to simplify. Okay, they can just ask you to simplify. You are the one who is supposed to know what is it that I am supposed to simplify. I'm supposed to expand the brackets. So if I expand this, they're supposed to go back here. Okay, let us just do this one for the sake of revision. But the rest, I want you to do them. We did this in a previous class, so I want you to go and watch that class on expansion of brackets. Okay, when we're expanding the brackets, so that you can properly understand. We said in the first bracket, it multiplies the second bracket. So this 3x here, it multiplies everything in the second bracket. So it's 3x, it multiplies x, okay? First term, first term. So it's going to be 3x squared. Then 3x, it multiplies -1. Okay, so it's 3x times -1, which is -3x. We are done with 3x. We move on to -1. -1, it multiplies x here. So what happens if -1 multiplies x? It gives us -x. -1, it multiplies -1, it gives us a +1. Okay, so we have to consider our like terms here. This is 3x squared. Okay, just this one is a typing error there. It's a writing. So this is 3x squared, okay? And we've got -3x, -1x. So you're back to your numbers, -3, -1. You are owing a 3. You owe another 3, so it's going to be -4, or you can just use your calculator. So that's -4x plus 1, or you can just use your calculator. So as you can see, if we reverse this to test, we can see it is exactly this one that we had. So it means our factorization here is correct, okay? So this is just a proof. It does not mean that whenever you're asked to factorize, you have to expand your brackets. No, you factorize. To factorize is to put in brackets. Remember, I told you to factorize is to what? To put in brackets. We are supposed to have our answer in brackets. To expand is to remove brackets. When the question is asking you to expand, you are removing brackets. There is to remove brackets. Remove brackets. Okay, so these are the two things that you have to consider. To factorize, you must see your answer in brackets. Expand, you are not supposed to see any bracket. You are supposed to remove every bracket that you are given. Okay, but this is not part of our class. Our part of the class is to factorize. So as you can see, like I said, these are all questions that we explained about here. They are not like straightforward to the idea of the question that, or to the idea of the topic, or this type of method that I want you to see. Let us consider maybe question number 5. Maybe we've got something to learn there, or maybe let us consider question number 7. It has got a lot of things there. All right. On question number 7, we are given 2x squared minus 7x plus 6. All right. So this is 2x squared minus 7x plus 6. So this one, we've got a lot of things to consider on this question. Okay. Like I said, the idea is not going to change. In this method that we are talking about, we said what we need is to obtain 2 brackets, which is actually true, that we are supposed to have 2 brackets. Okay, that when we multiply them, we expand, we get this. But how so? The coefficient of x squared is not a 1. Okay, sorry for that. This one is not a 1. And I said whenever the coefficient of x squared is no longer a 1, this one is not a 1. What you do is that you consider the first term and the last term, okay? So you're going to consider the first term and the last term. And on the last term, don't even focus on this sign. So for you not to be in confusion, don't be in confusion, guys. Just consider the number as it is. It's a what? It's a 6. The sign, we are going to check it later on. So this sign, we're going to consider it later on. So this is what you do. Considering your first term, okay? Considering our first need to write this as a product. Always think about this product. So as a product, 2x squared, which 2 numbers that we can multiply to get 2x squared? Think of 2 numbers that you can multiply to get 2x squared. So 2x squared is directed just 2, okay? Just 2 and 1, or 1 and 2. So you can just consider multiplying 2x and what? 2x and 1x. So you can consider multiplying 2x and 1x. 1x, guys, is same as what? Is same as x. Okay, I'm just writing 1x so that we properly see, but 1x is same as what? Is same as x. So that's your first term. Let's go to the last term. All right. Our last term is 6. But like I said, don't consider the sign. Just consider the number as it is. So we need numbers, 2 numbers. Just there must be pairs. Just a pair like this number, you multiply them to get a 6. So the first number that we can think of is 6 and a 1, and you can see that there's a 6 there, which is the one that you're considering, which is last term, which is 6. So you can think of multiplying 6 and what? And a 1. But is this the only number that we have that we can multiply to get a 6? No, there's so many numbers, okay? So how do we know those numbers? We just write this as a product of its prime factors. The smallest we said is 2. 6 divided by 2, which is a 3. 3 divided by 3, which is a 1. So 2 times 3 also, it gives us what? It gives us a 6. If we multiply these numbers on this side, they give us the number that we have on top, which is what? Which is 6. So we are saying 6 can also be a product of what? Of 2 and 3. So you can just start with the bigger number, which is 3 and what? 3 and 2. So let us just even multiply 3 times 2 so that we can properly see. If I multiply this, I get 6. If I multiply this, I get a 6. But for the product now of a constant, it's also a tricky part on a constant, because a constant, this one, you can also consider it this way, 2 times 3. Okay? Just like this one, you can also consider 1 times 6. You can also consider it that way, because there can be a reverse way of writing these numbers. So that's for a constant, okay? But for a variable, this one for 2x squared, which has got a variable, this one, don't consider that, this one, that one, just write as they are. Don't interchange anything. But for this, you can write 6 and 1, 1. But if you know your numbers in later on, there's no need for even you to write it that way. But let me explain it with a table so that you can be together. Like I said, these numbers that you have listed here, you tabulate them, you put them on a table. That is to tabulate, okay? So you're going to put them on a table, showing the the first and the last, because we've got a lot of numbers. That's why I'm having just an extended table here. I'm just gonna hope you're gonna be able to see it properly. All right, we move on to the other one. So this is our first. So on the first, there's nothing like much. There are just 2 terms there. So we don't consider a lot there. So this is our first term. Okay. So for the first term, there's nothing. There's just 1 term. Just 2 terms. I mean, 2x and what? And 1x. So you're just going to write your terms here. 2x, 1x. All right. But for the last one, that is where we have got a lot of things now. For the last term, we've got a lot of things to consider there. Okay, like I said, you can have 6 and 1. You can have it as 6 and 1 like this. We can have it as 1 and 6 like this. We can have it as 3 and 2 like this. We can have it as 2 and 3 like this. So you see, on the last one, there are a lot of numbers. It can also happen on the first term. It's not like it's the last term that can have a lot of numbers. It can happen on the first term. Not to say you interchange those numbers on the first term. No, you do not interchange your numbers on the first term, but it will be having a lot of factors, okay? It will be having a lot of factors. It can be like that. I just hope we can have an example like that. So like I said, we're going to have another class to further extend this class that we're talking about here. So this is our first term. I do not want us to have a confusion. So that's why I'm just covering here so that we can see this is our first term. So for the first term, you are supposed to represent it back, or you're supposed to consider it back to the terms that you consider on your last term here. Remember, these are the ones that we have, and you're supposed to take them diagonally like this, 2 versus 1, or it's 1 and 6 like this, okay? You move on here, 2 and 6, okay? 1 and what? 1 and 1. So you are testing, remember, the expression that you're dealing with, or the answer, or our factorization is supposed to be taken from where? We are supposed to work it from 2x squared minus 7x plus 6. Remember that. Okay. So considering that on this table here, I want us to consider, was this is our first terms, this one, 2x and what? And 1x. So let's consider taking them corresponding to the first part here. Let us consider this as our first part of 6 and 1. So it's going to be 2x like this, 1x, 6, and 1. So you consider them diagonally like this. You consider them diagonally like this. So the sign, it is you who is going to work with your sign, okay, to get a -7. But if you take it as it is, if you multiply here 2x and x, because it's diagonal, so it's 2x times x like this, what do you get? You get 2x, okay? 1x times 6x times 6, you get 6x. So if you add, you're going to get 8x, not -7. There's not even a negative there. It's just going to be positive what? Positive 8x. But there we need what? A -7x. Okay? This is a positive 8x that we get, which is not -7x. So do not give up. Like I said, it's a trial and error. You don't get the answer direct unless you have studied and studied and studied this topic. Then you just, okay, these are the numbers. It gets to that extent. But for now, it's a trial and error. So in order to get a negative, what do you think? Let's put a negative, okay? So you're going to put a negative, and to get a -7. Also, as you are writing the numbers, you have that an eyesight. Think of what is ahead. I'm supposed to get a -7. So let me think of having this as a negative and this also as a negative. There's a greater possibility of getting what? A -7 there. Okay? There's a greater possibility of getting, not to say on these numbers, but on the multiple, because this one is going to get a negative. But at the end, there's an 8 that we have. So 7 is not going to even come out. So you're not going to even get a 7 here. But let us just write, okay? Multiply this and this, you get -2x. Multiply this and this, you get -6x. You subtract, you get -8x, not -7. So these ones is totally out. It's totally out. All right, so let's move on to another one. We tried this one and this one. So this time I'm gonna try one on top. So like I said, it's a trial and error. We try, okay? You try. You keep on trying, okay? So let's use 2x. So you're gonna have 2x and 1x like this. This is 1 and 6. Diagonally like this, diagonally like this, okay? If you use them as a positive, there's no way we're gonna get a negative, okay? So let's try to put it a negative. Are you gonna put a negative here? If you put a negative, that's gonna be something like -12. So here there's no way here. If you put that way, let us just multiply 2 and this, what do you get? 2 and -6, that will be -12. 1 and negative, this is gonna be -x, which will give us -13x, because this is the same as -1x. So there is nothing also there, okay? There's nothing that we are also getting. So let us move on to another number. Here there's nothing, but you can try and try and try, okay? So let's move on to another number, 3 and 2. So you're gonna go back there, 2x, 1x, this is what? 3, this is 2. Okay, we try to multiply like this. 2 times 2, we get a 4. 1 times 3, we get a 3. So at least there's a possibility of getting a 7. But a -7x, in that manner, it must be a negative what? 7x. We are testing for the middle term now. We have to test. For the middle term, we have to test it. Okay, so let's test. This one and this one, it's going to be 4. Okay, diagonally, remember diagonally, guys? Okay, so it's going to be 4. And this one is going to be a +3. So it's not going to give us a -7. So to get a -7, what can we do? Let's put a negative here. Let's also put a negative there. Let's multiply. 2x times -2x, it's -4x. 1x times -3, it's -3x. -4 -3 is what? It's -7x. We have the middle term, which is this one. So this is the correct pair, the correct pair actually to use. So how are we going to use it now to factorize? Since it gives us exactly what we have on the middle term, we are going to factorize it now completely like this. So these ones, the ones that carry x, where there's x and x, you put them in the first. 2x here, x here. This is supposed to be 1x. These numbers with their signs, remember we're testing for these signs. Is it a negative? Is it a positive? we saw that it must be a negative. So this will be -3. This one will be -2. Now we have factorized this completely. So I just hope we have got something to take from this. It need practice, this method. It is going to be a little bit opposed with another method that I'm going to explain in another class. So that's what I said. That's why I was saying you are supposed to watch that class also, so that you can be able to differentiate between the two methods and you choose which one is best. Okay, this one, you have it in your textbooks. So you'll be wondering, what are they doing in our textbooks here? This is what they'll be trying to explain. Okay, so this is exactly what they'll be trying to explain to you. So you try. So if you check the last one, it won't give us, because there's no way that you can have two brackets that are, two factors from one trinomial. It's not impossible. All right, just gonna have one answer. So as you can see, like I said, some of the questions, they even stretch you further, right? They stretch you further, where we've got a lot of factors, just depending with the number that you're given. So sometimes even this can have a lot of factors, like this one for 6x². There are a lot of factors that you can consider here. If you check this one, let us just maybe try this one as our last question, then we'll check it using the other ones. We're going to check them using another method. So I want you to just at least try these questions. Okay, if you see that you're not obtaining the correct answers, because I told you how to prove, you expand your brackets. If you expand your brackets properly and you do not get this, then it means it's wrong. And also you must have your answers in simplest form. It's not just about expanding, because you might expand answers which are not in simplest form and they give you the answer, then you think it's correct. So try and see. But for anything that is having a challenge, let me know, so that we can at least revise that question on our next class. But like I said, we're going to do another method. All right, on number 9, we are given to factorize again 6x² minus 5x minus 21. So as we can see, this time, the factors here, the coefficient of x², this one, x², this number here, is no longer a 1. So we go back to that method, okay? So like I said, you consider, once this one is not equal to 1, you consider your first term and you consider your last term. Don't consider this negative. The negative we shall see that one when you are testing. Just use it as a 21. So we need products. We're going to find the products of what? Of the first term. So from your first term, what are your products from your first term? The products of 6x², two numbers. We just need two. It's like a pair. Two numbers that you multiply to get 6x². The first number that you must think of, or the first terms that you must think of, is where 6 is already there, which is what? Which is 6x times what? Times 1x. Those are the first two numbers that you can think of. Then the rest, you can go back to your product of its prime factors. 6 divided by 2, which is 3. 3 and 3, which is 1. So we've got 2 and what? 2 and 3, which is, we can just start with a bigger number, which is what? 3x, okay? So we're going to have 3x and times what? Times 2x. So like I said, for the first term, there is no need for you to interchange to say, in order for me to get 6x², I'm going to interchange and write it as 2x and 3x, just like what we saw for the constants. All right, that one is only for the constants, okay? For the variables, for 6x² or whatever that you have, just write whatever one way. If you write 2x and 3x, it's fine. Leave it like that, okay? If you use 3x and 2x, leave it like that, okay? Then you move on to the constant, which is the last term. So on the last term, what is our last term? Our last term is 21. What are the products of 21? So the first number that you're supposed to think definitely is supposed to be 21 and what? And 1. That is the first number that you must think of, 21 and 1. Then we interchange. The moment we think of 21 and 1, we must also think of what? 1 and what? And 21. Okay? The rest, the factors of 21, you find them from the product of prime factors of what? Of 21. Remember what I said on the product of what? Of prime factors. 21 can be expressed as a product of its prime factors. 3 into 21, that is 7. 7 into 7, that's a 1. So we also have a product of what? Of 3 and 7 to give us what? To give us 21. So we can write this 21 here as 3 times what? 3 times 7. Or we can even write this as what? You interchange 7 times 3. So you can even write it as 7 times what? 7 times 3. So let us just write or, so we do not confuse. This is or, we can have it that way. Okay. So this is what we have. So like I said, even if the first term can have a lot of terms, as you can see, the first term, there are 2 terms that you have to consider. The last term, there are 1, 2, 3, 4 pairs that you have to consider. So like I said, you tabulate whatever that you have, you put it on the table, okay? So you're gonna have a table for the first and last. So, but like I said, once we move on with our revisions, there's no need for us to have a lot of things like this. I'm gonna show you. I just want you to have an introduction so that you also revise as an individual so that you can also trace to see a shorter way of doing it. So this is what you're going to have here. Okay, so the first term, as you can see, there are 2. So you're going to just have at least extend our table a little bit, maybe somewhere here. So this is for the first what? This is for the first term. Okay, for the first term here. And this one is for the last term. Okay, so on the first term, there are only 2 things that you can consider: 6x versus what? Versus 1x. So you're gonna have 6x versus 1x. And then, like I said, 1x is same as what? Is same as 1. Okay, and 3x versus what? 3x versus 2x. So you're gonna have here 3x versus 2x like this. Okay, so this is what you're going to have on your first term. This is our first part here. Let me just highlight it so that we do not confuse with the last part. So this is our first, these are our first terms, this one that you're going to consider. So they are supposed to be affected with the last term. So you have to consider also what you have on your last terms, okay? So do not forget about that. So on our last terms, what do we have? On our last terms, we have got these terms here. We said 21 versus what? 1. So you're going to consider this 21 and 1. So this is 21 versus 1 like this, okay? We move on to the next one, 1 and 21. So this one, you write it in another way, 1 versus 21. So this is 1 versus 21, okay? You move on to the other one, 3 versus 7. So it's going to be 3 versus a 7. Then you write it the other way, 7 versus 3, okay? So it's going to be 7 versus 3 like this in another way. This is what you're going to do. So these are the only factors that you only have, as you can see, okay? So we've got the first and last. So let's consider this way to say from the first and last that we have in this case, it's a trial and error. Like I said, it's a trial and error method this way. There's no way we're going to hide. There's no way we're going to go around this one and say, you can just write your answer. No, 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 you'll be lying to yourself, all right? So the whole part of this exercise, it was a trial and error. So I cannot lie to yourselves, guys, and say, these types of questions, you can just do them direct. No, 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 no. That one is going to be a straight line. Okay, anyways, like I said, it's a trial and error. So on this table, you're going to try to write them, take them from the first, okay? So if you consider 6 and 1, okay? If you consider 6 and 1, it's going to be a trial and error to say this will be 6x, this will be 1x. Maybe you consider 6 and 1 versus this one, 21 and what? 21 and 9. 21 and 1 like this is going to be 21 and 1. But remember what you're supposed to be considering. Okay, you're going to have your diagonal like this, but remember you're supposed to consider your expression 6x squared minus 5x minus 21. Okay, so this is 6x squared minus 5x minus 21. So if we consider getting a negative 5 on the addition where I multiply these and multiply these and get a negative 5 there, it's so far. It's so far, very, very far. Because I'm supposed to get a negative, I'm working with the middle term. I'm supposed to get a negative 5. And I'm so far. So what can I do? At least let me, but you can do that, guys. Like, I'm not saying it's wrong. You can do that, try as much as you can try. So let us go to this 3 and 2 at least. We are a little bit closer, okay? 3x and what? And 2x. So you can consider your terms 21 and 1 again. If we check this, we are so far. If we use this 21 and 1, even if we take a negative, these numbers 3, this will be 40 something. To get a negative 5, these numbers, they are so far. So you move on, 1 and 21, you move on, and so on, and so on, and so on, and so on. This is what you're going to do. You have to move on until you get the 1. Okay, so I'm just going to move on to this one, 7 and what? And 3. Okay, on 7 and 3, this is what we have. Okay, so I'm supposed to remove this. I want to write 7 and 3. So like I said, you're going to try this and so forth. Okay, guys, I tried these numbers. So I want you to try this one and see. But you're going to see that it's not going to work even if you put a negative. But on this one, let's try. If we multiply as it is, we're not going to work because this will be a positive. If I multiply this, it's going to be a positive, and this will be a positive. Remember, you're supposed to do this what? Diagonally. I now hope we all understand this part, okay? So diagonally is going to be positive 9x if I multiply. Okay, if I multiply 2x, and this is going to be positive 14x. If I add, guys, look what I'm getting. It's going to be far. So let me think of having a negative, okay? And in order for me to get a negative, I can think of this one having a negative first. And this one having a negative, but because I'm supposed to get a negative 21 here, it can't be this one is a negative and this one is a negative, because if I multiply this, it will be a positive. Remember, these ones represent the last, they represent the last term, okay? So it can't be that I have this one as a negative and this one as a negative. If I multiply this, it will give us a positive 21, not a negative. So that's why I'm saying it's impossible. So when you see the last term as a negative, as you try your values, you're going to try them 1, 1. You try this as a negative, then the other one, you try this as a negative. You try it like this. You try it as 3x going to minus 3 this time. And this 2x going to what? To positive 7. Well, there's no way that you're going to multiply these two numbers and get a positive. Positive and negative gives you a negative. So one number has to be positive, another one negative. So like I said, it's a trial and error. So let's try on these ones. So like I said, those ones, try them, but these ones are the ones that I'm going to try with you. So let's multiply 3x times 3 times 3. So if you multiply 3 and 3, what do you get? 3x times 3x, you get 9x. Okay, 2x times minus 7. 2 times minus 7 is what? It's minus 14x. Then we subtract 9 minus 14. It's what? It's minus 5x, which is exactly our middle term. Exactly our middle term. Exactly this term of minus 5x. So meaning to say, I can be able to factorize this one. I have my two brackets, okay? So these ones, x and x, I said wherever there's x, you put them on the first. 3x here, okay? In the first bracket, you're going to have 3x. In the second bracket, on the first term, you must have 2x. So that if you multiply this, we get what? 6x squared, okay? Then these numbers with the negative 7 here and a positive 3 here, or you can even write whatever that you want, the way that you want, okay? So this one gave us the correct answer. Let us try this one, okay? Because it's a trial and error, guys. Let's try this one. Okay, let's multiply 3x times minus 3. It gives us minus 9x. 2x times 7. If you multiply 2 times 7, it's what? It's a 14x with this x. Okay, let's add. Minus 9 plus 14. I want you to do this on your calculator. Add. Minus 9 plus 14. Can you add? Can you add? What are you getting? 5x, not minus 5x. It's a positive 5x. So this one is wrong. This combination is wrong. It's a wrong combination because it must give us the middle term. We multiply this, we are getting this negative 21. We multiply this, we get 6x squared. But if we add now on the diagonal part, that one, the product of the diagonal, it is not giving us the middle term. So it disqualifies it to be used as your factors. So if it is disqualified, you cannot use it on your factors. So this was the actual one that we can use to get, that we can take from our factorization of this bracket. So like I said, we're going to do more questions. So I want you to try this one, expand your brackets, okay? Expand these brackets here. You must get this answer that we had before, which is this one. So these are the steps. First step, on your factorization of this nature, where the coefficient of x squared is no longer a 1, you have to find the products, the factors of the first term and the last term. Don't consider the sign on the last term, just take it as a positive. From those factors that you have determined, tabulate them, put them on a table like this, showing the first terms and those your last terms. Then determine a combination through the horizontal, through this concept of taking the first. If you consider this, you consider 6 and 1, you must take them like this here, 21. So it must be 6x, 1x, 21 versus 1. You take them diagonally. You choose the signs that you're going to put here. The sign now consider to say the term here, the term, it's negative 21. So I'm supposed to consider to say one of these numbers must be negative, okay? So this one can be negative. The other one, pause. I try 6x again. I move on to another combination. It can be of 6x and 1x. And this 21, this time as a positive, 1 as a negative. So I try to multiply and subtract, multiply whatever that I get here, 6x and 1x, I get 6x. 1x times 21, I get positive 21. I add and see if I get what is in the middle term, which is this negative 5b. If I do not get this, it means those are invalid. I move on until I get, so you have to also take values which are a little bit closer to your answer. Closer to your answer. So this one, it's a nice method, yes. And it's a method that we see also in our textbooks now. But there is another method, and I've been using that method if you have been watching your videos on the final exam questions like full papers or any exam question I've been talking about that type of method. So we're going to have a class, but talking deep about that method or exploring about that method to say, what is it that you're supposed to understand so that you'll be able to choose between these two methods, okay? Between the two methods of factorization of our trinomials, but this time the coefficient of x squared is not 1, meaning to say from our ax squared plus bx plus c is equal to 0. We are saying a is no longer equal to 1. So if a is no longer equal to 1, it's a little bit longer way that you are supposed to take. We were supposed to do this even if a was equal to 1. But just because a was equal to 1, it can be taken in a shorter way. But we couldn't see that. But we were actually doing this in disguise. Okay, then there are questions like this. As you are going to try your questions, I want you to try questions. Then there are questions where you can remember the golden rule of your factorization. Questions like question B, this one, 4x squared plus 10x minus 6. You can even start by factoring the first term, which is common, which is 2. So if I factor out 2, I'm going to remain, I divide 4x squared, divide by 2, I get 2x squared, okay? 10x divided by 2, I get what? 5x. Minus 6 divided by 2, I get minus 3. So this is the one that you're going to fit. This one, you are going to factorize this, okay? The way that we have been doing the other questions. But your answer is going to have 2 at the end. So you're going to have 2 and 2 brackets that you're going to have from this trinomial that is in this bracket, okay? So wherever there are common terms like 15, minus 18, 3, factor out the common term first. Remember the golden rule, when there's a common term, you have to factor out that common term first, okay? But for this one, it's not going to change. For this, for this one, 4. If you consider that one, let us just take this one. Maybe some of us might have confusion. 4p squared plus 7pq. So this is 4p squared, okay, plus 7pq plus 7pq plus 7pq. Okay, let us move on here. Minus 2p squared, okay, minus 2q squared, like this. Okay, let us save this as our last example, guys. Okay, let's see this one. On this question, I want you to be clear. There are two constants. There are two variables, p and q. So you're going to consider this as your first term, okay? And there's nothing that is common here. You can't factor out 2 because here it's a 7, okay? So you can't factor out p. Here we do not have p. You can't factor out q because here we do not have q. So there's nothing that is common, but just we've got a variable at the end. So if this one, you consider it as your first term, this one is going to be your last term. So like I said, don't consider the sign, just consider the last term as it is. So this is your last. So we have got our first and we have got our last, okay? So our last, we are going to consider the sign later on, not now. Now just take it as a positive 2, okay? So that you do not have confusion, negative, positive. That one you see it when you on the trial and error, okay? So like I said, you're gonna have the products of the first and the last, okay? So from our first, we're gonna try to have our products here, which is 4p squared. So two numbers that we can multiply to give us 4p squared. The first number you have a 4. You have to consider 4. So it's going to be 4p and what? And p, which is 1p. Okay, 4p and 1p. If you multiply this, we get what? We get 4p squared. So if you multiply this, because it's a product, if you multiply this, we get 4p squared. Also, for us to get 4p squared on 4, you can consider 2 and 2, factors of 2. So this can also be 2p times what? Times 2p. So these are the factors only for 4. I think these are the only factors that we have. Yes, this is what you only have, guys, okay? If there's any factor, there's no other factor here. So now let us consider the last. So on the last, this is what we have. What is it that we have on the last? We've got 2q squared, okay? So we have to consider q squared. That time it was just a number. Now there's a letter which is q. So you have to consider having that q also. Q must be there. Okay? So let us consider that, having q. So but just consider 2, not q. Q is there, but just consider having q, okay? Q is there, but consider the number 2, factors of 2. So you can have 2 and 1. So this will be 2q and 1q. So that it gives us 2q squared, okay? So that's a product there. And like I said, when on the constant, on the last term, you can interchange. So once you say 2 and 1, you can also say 1q times what? Times 2q. This can only happen on the last. These are the only factors of 2, 1 and 2. So we can even interchange. If it was 2 and 1, we can write as what? As 1 and 2. So now we are going to take this on our table. We tabulate what we have from our what? From our first and last from this one. Okay, so let us just put it here on top here like this. So from your first, okay, let us just have our table here so that we can conclude at the end. So this is what you're going to have. Okay. So our first is, there are two things that you have to consider on your first. So you're going to have two things to be considered here. So this is our first. We have to consider what? That's 4p and what? And 1p. So this is going to be 4p, 1p. Okay. 2p and 2p. So this can be 2p, 2p like this. Okay. So this is what you can think of here. And we consider the last. Okay. So for the last term, we're going to consider there are two also combinations. There are just two combinations there for 2q and what? And 1q. 2q and 1q. And also for 1Q. And remember, I said this one you can interchange for the last 1Q and what? And 2Q like this. So this is what you're going to have. So now, like I said, at this stage, this is where you're going to do your trial and error. So it's a trial and error. You try because you consider that I'm supposed to get what? I'm supposed to get 4p squared. I'm supposed to get 4p squared, 7pq minus 2q squared from these terms. So if I multiply this 4p and 1p, I get what? 4p squared, which is true. Okay. If I multiply first term 2p and 2p, I get 4p squared. Okay. But on a condition that now I have to consider for the middle term. So for this part of the middle term here, this one, because now you have to consider the middle term, which is 7pq like this one. Just consider numbers to say, how can I obtain 7pq? Because you're going to take your terms in a diagonal. So, and also considering that there's a negative, one of these terms must be a negative here. So it can be maybe this one is a negative, or it can be this one is a negative, or it can be this one is a negative, or this one is a negative, in order for us to obtain what? Negative 2q squared. So you do it as it's a trial. In fact, it's a trial and an error. You are supposed to know it that way. You try until you get the answer that is correct. So let us just try to say we take our first here with the 4p and what? 1p. Like I said, it's a trial and error. We take 4p and 1p. Corresponding to the last, you must correspond to the last. So to the last, you're going to take 2q and 1q, okay? So let's take 2q and 1q. Okay, in order for us to get a negative 2q squared here, how can you get a negative? It means one of these must be negative. Okay, so this one can be negative, or this one can be negative. So you're going to have another condition here, 4p, 1p, 2q, and 1q. This one as it is this one, but we just interchange and give this one a negative, because if you multiply this, your lasts, they must give you a negative 2q squared. So if I multiply this, I get a negative. Not to say it's gonna, if it was a positive, that's where you put negative here. But this one is a negative, so it must be negative, okay? So let us do it diagonal and see. So if I multiply this, what do I get? 4pq, okay? 4p times 1q, I get 4pq. Let's multiply this. 1p times this minus 2, I get minus 2pq. Okay, this is what I have. And if I subtract, there's no possibility of getting a 7. It's worse, okay? It's negative what? It's positive 2. It's going to be 2pq. So like I said, it's a trial and error. This one, it gives you negative 4, positive 3, which is going to, positive 2, it's going to be negative. So to get a 7, we are so far. We are so far to what? To 7. So what can we think of? Let's think of maybe, okay, this one, let's think of having, why am I getting a 2 here? All right, this is a 4, which is 1. Okay, let's think of 2 and 2. Maybe we're gonna have 4 there, 4 there, maybe, and a q. Okay, but this one has to be a negative also. It has to be a negative q. So it's a trial and error, guys. Let's move on. Well, this one we are so far because this will be 4pq, and in whatever way that you're gonna have, it's gonna be 2 something like that. Okay, on this one. Okay, this is one that we did. I'm wondering what's happening. Okay, this one is gonna be 4pq. Okay, and this one is gonna be 8. Sorry, so this one is close, very close. Yes, this one and the last one, this one. Okay. So it's a trial. Trial means trial and error. So if you do not make errors here, you are not, you are a machine. You are actually a machine if you don't make errors on this one. So this one is very, very close. This one, let's consider this, because this will be the first. Okay, on your first, you've got 4p and 1p. Your last is 1q and 2q. So if we consider the sign that is supposed to be a negative, we're going to take this as a negative here. Okay, so let us consider diagonally. If we multiply this diagonally here, that's 8 minus 1, which is a 7. So if you multiply this, it's going to be 8pq minus pq, 1pq. Okay, so this gives us what? 7pq. You can try interchange. You see that this one cannot give us what we want. If we put it as 4p, 1p, and we interchange the, like I said, don't interchange the negative on this one because this one is a positive. It cannot be a negative, okay? So you interchange on these ones, on the constants. So you're going to interchange and say it's 1q this time, and this one is minus 2q. So if we multiply these two here, you get what? Negative 8pq. If you multiply these two diagonally, you get a positive pq. So if we add, we are going to get a negative 8 plus 1, it's negative 7pq, not a positive. So this one, it is disqualified totally. It cannot work. So you only work with the part that gives you exactly the middle term, 7pq. This one, it gives you 7pq. These ones, if you multiply them, they give you 4p squared, okay? These ones, if you multiply them, they give you negative 2p squared. Everything must get back to this one. Once it gets back here, when it gives you exactly what is here, you write this first in the first part, 4p here and a p here. The last on the last, okay? So it's going to be last minus 1q, which is minus q, plus 2q on the other side. This is 2q is going to be a positive. So we have factorized this bracket, this whole factorization here completely, fully. We have factorized fully. So like I said, there's a lot on this type of factorization, and I feel like we need to work with more questions because we've been asking guys, how do we actually deal with this type of factorization? There are so many ways that we can actually deal with this factorization. So you are going to pick the best method, okay? Like I said, I'm going to come back with another method. So you pick the method that is good for you, that you understand, okay? It's not like you are forced, because you see this in most of our textbooks. And now, like, it's a copy thing, okay? One textbook, it copies another textbook, another copy. So it's like a copycat, what is happening nowadays. So you think that this is the right thing, or I'm supposed to do it this way. No, there are so many methods, okay? So many methods. It's only that we just need to sit down, work those methods together, revise them together, so that you'll be able to know which one is best for you to choose. We still have a time to revise, unless you are revising this way. No, effectively, you are revising this for exams. This is too late. Revise question papers for exams. Okay, so that's it, guys. We shall see in our next class. Let us try to just work as much as we can.